Good day, wonderful students. It's always my pleasure to welcome you to another exciting episode of Mathematics on Schoolonair. Today we are going to start looking at another topic, and I'm sure it's going to be very, very educative and interesting. It's one of the topics that have newly been introduced into the SSC mathematics curriculum, and that's differential calculus. Okay, in calculus we talk about differentiation and integration, but for a start we start with differentiation. So we are looking at differential calculus, and today we are going to start with the concept of limit, because we are going to be making use of limiting values of variables in the course of learning differential calculus. Okay, so today we are looking at the concept of limits. Okay, so get your writing materials, your pen and your jotters. Of course, you're going to have to put down a few things that you will have to refer to later. Okay, so if you are set, why don't you let's start learning the concept of limit. Okay, so if we talk about concept of limit, one important thing we must always know is a function. We will make use of this word often and often, so it's important to know what a function is. What is it that we call functions? A function is always represented by that small letter f. The lowercase f is what is always used to designate a function, and a function is always referring to two other pairs that do not have the same variable or the same item in the first part of the other pair. So in other words, a function denoted by f is a relation in which no two different other pairs have the same first component. Okay, two different other pairs and their first component is never the same. So when you have such arrangement, we have what is called a function. So that's what a function is. I'm going to give you an example of what they look like. Okay, so an example is I have this 1,3 and I have 2,4. Okay, this is another pair, 1,3. Okay, you've learned that when we're learning something on coordinate geometry, x, y, x, y, x1, y1, x2, y2. Remember? Okay, so when you have two other pairs that do not have the same first component, this is 1,3, this is 2,4. The first component here is 1, the first component here is 2. So that forms a function. Okay, we have another example here. This is like a column matrix or a column vector, 2, 4, 5. In this case, we have x, y, z, and you see the first component here being 2, the first component here being x. Okay, so we can have things like f such that x is equal to 3x minus 1, and so on. That's what a function generally is. So in other words, a function of x is a value which depends on the value of x. Okay, so if I say f of x is this, it means the value of f of x depends on whatever x is. So x in such case is an independent variable, while f of x, which is a function of x, is a dependent variable relying exclusively on whatever value x takes. So that's what a function is. Okay, so if that is noted, let's quickly move on to some symbols that are used to represent a function. Okay, often you're going to see things like f of x. Okay, this is pronounced f of x. If you see f into x, g into x, h into x, k into x. Okay, all of those are used to denote functions of x. Okay, so when you see things like this, we read it as f of x. Okay, so in this case, I will say this is f of x. I will say this is g of x, h of x, and k of x, and so on. So whatever is used to denote, but these are the common ones that you see to represent a function: f of x, g of x, h of x, and k of x. Okay, so it is read k of x, not k bracket x. Okay, all right. So that's what those symbols that are used for functions and how they are read. Okay, now quickly let's now move on to see some examples of functions. Okay, so I can have the function represented in this form: y is equal to f of x, which is equal to 6x squared. So what that means is that the value of y depends on the value of x. So meaning that y in this case is a function of x, which of course is equal to 6x squared. Okay, we can have f of x is equal to x cubed minus 4. We can have f of x is equal to sine 3x. We can have f of x is equal to log x. We can have f of x is equal to e raised to power 2x. So in all those examples, we realize that the function will depend on whatever value x assumes. So in this case, for instance, if x takes the value of 1, what that means is that y will be equal to 6, because 1 square will be 1 times 6 will be 6. And in this case, if our x takes the value of 2, that means my f of x will be 2 raised to the power 3, which will be 8 minus 4. So f of x will be 4. So the value of that function will depend on x, which is the independent variable. So that's the general definition or description of a function. Okay, I hope that is noted. So let's quickly move on to the limit of a function, which is exactly what we actually want to learn today. What's the limit of a function, and how do I obtain the limit of a function? Now, if we are given, remember, we know what a function is now. Now, if we are given that f of x is equal to ax cubed plus bx plus c. Now, as the value of x approaches a constant p, what it means is that f of x will also approach ap squared plus bp plus c. In other words, if f of x is equal to ax cubed plus bx plus c, okay, and the value of x probably increases or decreases until it gets to a value p, then the value of the function f of x also will definitely approach this value, because x will now take the value of p. So we have p squared plus bp plus c. So that's what generally the limit is all about. So whatever value that x approaches, then the function that depends on the value of x also approaches that value. Okay, so I hope that is taken. So in other words, what we are saying is that the lim, now this is what is, you look at this now, this is used to describe the limit of a function. You see that acronym lim, L-I-M, and then you see at the bottom showing the value that the x is approaching. So in other words, we write lim, that is the limit of f of x as x approaches p. You see the arrow going from x to p. The limit of f of x as x approaches p is equal to, we have lim, that is the limit of the original value of f of x is ax squared plus bx plus c. Now, as x approaches p, p takes the value of x now. So we have ap squared plus bp, remember we used to have x here before, plus c, which is the constant. So that's how to obtain the limit. You just substitute the value of whatever x approaches for x in the given function of a limit. Okay, so I hope that is taken. Now let's look at the methods of calculating the limit, okay, because limits are obtained depending on the kind of function that we have. So what are the methods of calculating the limit? There are various methods. We have the direct substitution, we have the method of factorization, okay, and so on. So let's look at the various methods involved in calculating the limit of a function. Now the first one, like I said, is by direct substitution. Calculating limit by direct substitution. So how do we do that? Let's take a look at this one. This case says evaluate the limit of 5x plus 3 as x approaches 0. The limit of 5x plus 3 as x approaches 0. So as x approaches 0, what that means is you substitute the value of 0 for x. So when you put the value of x equals 0, what do we have as the limit of that function? So that's what we do in direct substitution. So in this case, as we obtain the limit 5x plus 3 as x approaches 0 by substituting the value of 0 for x in the function that we have. So the function used to be 5x, so we put x equals 0. So we have 5 into 0 plus 3. And of course, when we multiply 5 by 0, we end up with 0. So 0 plus 3 is 3. So what that means is that the limit of the function 5x plus 3 as x approaches 0 is 3. I think that is very simple enough. Substituting the value of x, 0 for x in the function gives us the limit of that function. Okay, so that means the limit of f of x plus 3 as x approaches 0 is equal to 3. So you must always put this at the bottom of the limiting sign here. X approaches 0. Okay. All right, so that is that with that one. When we talk about direct substitution, let's take a look at another quick example. This one says evaluate the limit of x squared plus 3x minus 3 over x plus 2. The limit of x squared plus 3x minus 3 over x plus 2 as x approaches 1. As x approaches 1. So how do we obtain that limit? Okay, so let's go on and see how that pans out. Okay, so the limit we have, that's it. X squared plus 3x minus 3 over x plus 2. But we are told as x approaches 1. So by substitution, we'll put the value of x as 1 in the given function. So I put x equal 1 so that I have 1 squared, which will still give me 1, plus 3x, that's 3 into 1. The value of x now is 1, then minus 3 over 1, which is the value of x now, plus 2. So what do we have? 1 plus, this is 3, that gives us 4 minus 3 should give us 1. Then we'll end up with 1 all over 3. So we have the limit of x squared plus 3x minus 3 over x plus 2 as x approaches 1 being 1 all over 3. Okay, so that's simplified right out there. 1 plus 3 into 1 minus 3 all over 3, giving us 1 over 3. So that is by direct substitution. Okay, I think by direct substitution is simple enough. So let's move on quickly and see what other ways do we employ in finding the limit of a function. Okay, so the next one is limit involving factorization. Now, in this case, the time we have to use method of factorization is when you observe that by substituting the value of x, the limiting value of x in the function given, you realize that both the numerator and the denominator will give you 0. Then you have to find another way around it. If you put the value of x, the limiting value of x in the function given, and the denominator and denominator gives you 0, you know that is not determinate. 0 over 0 is not determinate. So you have to think of what else to do. And in such situation, we try factorization. So let's take a look at how that is done. Okay, like I said, when the fraction becomes 0 over 0, you know such limit does not exist, 0 over 0. So we obtain the limit for such a function by factorization. We'll take a look at an example in such case. Example is that it says find the limits of the following. The limit of x squared minus 2x minus 3 over x plus 1 as x approaches minus 1. The limit of the function x squared minus 2x minus 3 over x plus 1 as x approaches minus 1. So you observe in this case that if you put the value of minus 1 in here, this will become 1, okay? And this will become minus 2 into minus 1, which will give me plus 2. So I'm going to end up with 1 plus 2, 3 minus 3, 0. And if you repeat the same thing here, this will also give me 0. So the numerator and the denominator become 0, which is indeterminate. So we think of other ways around it, which will be factorization. Okay, so how do we go about that? Quickly, let's take a look. Now, the limits of x squared minus 2x minus 3 over x plus 1 as x approaches minus 1. So you realize if you put the value of minus 1 there, okay, let's try that out. Minus 1 squared will give us 1. Minus 2 into minus 1 gives me plus 2 there, and I have minus 3. So I have minus 1 plus 2, which is 3 minus 3. All that goes down to 0. And at the denominator, I have minus 1 plus 1, which also goes down to 0. Okay, so that is not determinate, does not exist. So we better factorize what we have. So we say since that does not exist, we therefore factorize the polynomial. So if you factorize this polynomial, x squared minus 2x minus 3, by method of factorization in your quadratic equation we've learned before. So this will factor out to x plus 1 into x minus 3 over x plus 1. And in that situation, we'll be able to cross out x plus 1 over x plus 1, leaving us with x minus 3. So if we are left with x minus 3, then we can input the value of x being minus 1. Then we have minus 1 minus 3. Okay, so what we have right there is minus 4. Okay, so we have the limit being minus 1 minus 3 to give us minus 4. So when you have the denominator and numerator giving you 0 by substitution, then you factorize to get to where you are going. I hope that is clear enough. So limit involving division of terms is the other one we have to look at. Limits involving division of terms. In this case, x approaches infinity such that we have the numerator and denominator being infinity. And of course, this is indeterminate or indefinite because we don't have a specific value for infinity. So when that happens, what we do is to divide both the numerator and the denominator by the highest degree of the variable, which of course in this case is x. Okay, so when you have a limiting value of x approaching infinity, we divide both the numerator and denominator by the highest value of x. Okay, so we'll just take an example there and then we'll round it off today. So look at an example. Find the limit of 2x squared plus 3x plus 7 over 8x minus 9x squared plus 3 as x approaches infinity. So if x is going to approach infinity, then what we have to do is to divide both top and bottom of the function by the highest power of x, which is x squared in this case. So what we do straight away is to divide, that's the solution. We have the same function repeated there, and then we divide by the highest power of x, which in this case is x squared. So if we try to do that, this is what we get. Okay, so we divide all of them by x squared. Okay, so this goes down to 2. This goes down to 3 over x. That remains 7 over x squared. This goes down to 8 over x. This goes down to minus 9. And then that leaves us with a 3 all over x squared. If we divide both, top and bottom by the highest power. Okay, so that was what I was mentioning. Okay, after division, we get that. And then as x approaches infinity, what do we have? As x approaches infinity, this becomes 2 plus this becomes that, and then 8x over infinity minus 9, 3 all over infinity squared. Of course, we know the value of infinity is extremely large. So as it becomes extremely large, all those ones that are to be divided by infinity, they move down to 0. Okay, this is to be divided by infinity, goes down to 0. All of them goes down to 0. So leaving me with 2 over minus 9. So the limit of that function becomes minus 2 over 9. Minus 2 over 9. So we have looked at 3 methods of obtaining limits. 1 is by direct substitution. 2 is by factorization. That is when you realize that by substitution, numerator and denominator becomes 0. And then the third one is by dividing by the highest power of the variable. That is when you realize that you are being told that x approaches infinity. All right, so that's just the basic thing about limits. There is not much about it. Okay, so but before we go today, why don't you just try and lay your hands on this one? Evaluate the following limit. Okay, lim 4x cubed plus 2x plus 5 over 8x minus 9x squared plus 3 as x approaches infinity. And then the second one, x squared plus x plus 7 over 8x minus x squared plus 1 as x approaches infinity. Okay, when you are done with that, you send your answers as usual across to the address you have right below your screen. You can be sure I will get them and do justice to them. That will be the very convenient point for me today to say goodbye on this episode of Mathematics on Schoolonair. I hope you've had a nice time. Okay, yeah, I've also enjoyed myself. So why don't we make it a date on another episode when we shall be looking at something else still on differential calculus. Till I come your way again, I will encourage you, keep solving mathematics. It's goodbye and God bless you.